Hello everyone and welcome back to another video. Today we'll see how we can see our output directly into game view. So for example, if we want to see the output, we have to go to main camera and double click on the output. So we need to see this image directly here. So what I'm going to do, I'm going to create a new UI raw image. Yeah, and then going to from canvas I'm going to change render mode to screen space camera. Also I'm going to choose and for render camera main camera you just need to drag and drop the main camera here. Also yeah, the current box is here. I'm going to make it just a little bit here, so I do that. I'm going to 2D mode and guess I'm going to drop the box here. So yeah, everything seems fine here in game view. Okay, what I'm going to do next, I'm going to open the XR script and I'm going just to copy the name of raw image. I'm going to create a new public variable of type raw image. I'm going to make it image, for example. I'm going to make sure just to include right namespace, which is Unity engine.ui. I'm going to assign the texture. I think it should be texture. Yeah, I'm going to change the texture properties of raw image to set it to our output. So raw dot I said it was image. This one is the name of our variable we have created. This one dot texture equal to output underscore output, sorry. So I'm going to save everything and we should be able to see output directly in game view. I forget to assign the image, so I'm going just to drag and drop the image here, and we now should be good. Yeah. This was for first part. Second part, I'm going to discuss or play with the XR shader and new ray tracing shader. So let's discuss a little bit the output currently we have. For example, here if we hit something, we're going to first going to dispatch array from center of every pixel we have in our screen here. So if we hit something, we're going to set that pixel to red. If we hit nothing, we're going to set it black. So for example, if I just move the cube to the left or the right, yeah, if we hit the cube, we're going to output red. So we can just change the color here. For example, if we hit nothing, we're going to output black or nothing. So I'm going to open new ray tracing shader. So instead we output black for if we hit something, we're going to output, for example, green. So what I'm going to do, I'm going in here shader mesh void main mesh shader. I'm going to change payload.color to green, so it should be 010. So let's see what's going to happen here. Yeah, so now if we hit something, if we hit nothing, I mean, it's just going to be green. So what actually this shader here, the shader mask, is going to be, what's going to be happening if we miss something, if the array we dispatching currently it doesn't hit anything in our scenes, we can just output directly what we want to do, or dispatch another array, I think. So no, yeah. The another type of shader we're going to work with it mainly, but we're going not change it that much, is main array generation shader. This one is going to dispatch array from every single pixel we have in our camera. This is set up for how we get the direction of our pixel mainly, and the origin, or where this ray starts, we're going to be the current camera position. So this whole thing is just to calculate the direction of the ray. So what we're going to make uh, the main component here is that we ray description ray. So ray, this structure have, for example, origin, direction, tmax, and tmin. So the origin defines where the array start, the direction defines the array direction, tmin and tmax defines the segment along the array where we want to check for intersection. So for example, if we set tmin to 0, it's just going to start from where defines the origin. But if we set it, for example, to 100, along that ray is going to start from 100 to 10,000 or 1,000, I mean. So the ray going to start from camera position. Along the ray, we're just going to include only that segment from where define tmin and tmax. Also, we need to define payload. Payload is just a structure that we can pass data from, for example, recognition to hit shader, to another type of shader, and so on. So the data here is passed from ray to another ray, and next part we need to define the miss shader, which is going to be this one. So if we check the output, for example, I check the new Raytracing shader, we see here miss shader, it gives the index. For example, index 0 name main miss shader, which is going same name that we have here. So this one is defines the index we're going to use if our ray does not hit anything. So in order to dispatch ray, we're going to use this intrinsic trace ray. So first we're going to define the acceleration structure that we have been created before. For now we're going just to ignore this part. Here we define the miss shader, here we define the array we want to trace, and here's the payload. This main ray generation header, we're not going to change that much, so most time will be the same. And now let's move to the second part, which is a closed head shader. This one defines what's going to happen if our ray hits something. So we have here the signature of closed head shader. We have the payload and another structure which is going to define where the ray hits the geometry or the position of intersection point. in order to know the actual position, we need to use some other helper function from Unity. For now, we just, for example, for now, if we had something that we output, for example, the red color, so let's make it an output another like blue. Yeah, let's try it. Yeah, as you can see, the color change from, I think, was red, now it's blue. Also, the interesting part about close hitch main is that you can also dispatch another array or as many array as you want, but the limit defined by here in new Raytracing shader is max recursion depth. This one array, if for example close head shader executed, it can also dispatch another array, and if that array hits something, the close head shader will execute again, and this one execute maybe can dispatch new array. The maximum depth you can have, or max recursion depth, is defined here. I think is according to the DirectX-Specs, it should be at maximum. It should be can be 16, if I'm not wrong. Oh, so what's going to happen here? You can just change the payload we defined it before, or we can dispatch another array, or we can ignore the hit. So this for this video. Next video hopefully will, I think it will be long. We're going to discuss how to create light and shadow with with raying, or how to simulate that with ray tracing exactly. So that's for this video, and see you next time.